All right, taking a quick finish up look here at inverse functions. I'm now going to run over, I'm on page 14 in your notes here, page 14. Starting with if you have a little bit more complicated example like this example we're on here, finding the inverse function. We're still going to follow the same process as we did before, which is we're going to switch this to a y. So we got a y equals 1/3 x cubed plus 2. And then we're going to flip these variables. So now it's x equals 1/3 y cubed plus 2. Resolving for y, we have to make sure that this y cubed is the last thing that we mess with. The very last thing we're going to do way down over here is cube root. That's the last thing. So I have to take care of all of this other stuff first. So how I'm going to do that is I'm going to start by subtraction. I'm going to subtract 2 to both sides. So I end up with x minus 2 equals 1/3 y cubed. Now to get rid of the 1/3, I'm going to times by 3, so that will cancel that out. Take everything over here times 3, you get a 3x minus 6 equals y cubed. Take the cube root of both sides, because now I have my y cubed by itself. And your final answer here, I'm going to rewrite it in function notation, should be f negative 1 of x, which means the inverse of f of x, equals 3x minus 6. And you're good. I am going to run over these last two examples as well, and then I'm going to have you try this checkpoint on your own. So these last two examples, same kind of thing, except now I'm going to have to do a 5th root at the end and maybe a 4th root at the end. First step here is I'm going to rewrite this with a y and an x. So y equals 2x5 plus 2. And I'm going to flip-flop these, so you get x equals 2y5 plus 2. You have to subtract 2, then divide by 2, then 5th root. So in that order, get a different color here, I'm going to subtract 2 to get x minus 2, 2y5. I'm going to divide by 2, so you get 1/2 x minus 1 equals y5. And then you 5th root both sides. So you end up with f, I'm going to tell you what, we're going to write this in function notation. F negative 1 of x equals the 5th root of 1/2 x minus 1. And that is the inverse function of this one that you started with right there. Last example I'm going to do, and then I want you to try the checkpoints. Here, I'm going to rewrite it again. Y equals 3x to the 4th. I'm going to flip the variables, so I get x equals 3y to the 4th. I'm going to divide by 3 first. I'm going to write this as 1/3 equals y to the 4th, and you 4th root both sides. So, you end up with y equals, we better go up a little ways here. Y equals the 4th root of 1/3 x. Now there is a slight problem with this. We can't have a radical on the bottom. So what I'm going to do is you can't have a 4th root on the bottom. So you end up with y equals the 4th root of x over the 4th root of 3. I'm going to multiply this like we've done in previous videos to get rid of the 4th root of 3 on the bottom. So I know that I have to take this times the 4th root of 27. Why 27? Because 3 times 27 will give you your 81. We'll give you the 4th root of 81. And the 4th root of 81 is 3. And then I successfully have it onto the bottom. So if I take the if I take the bottom times the 4th root of 27, I also have to take the top times the 4th root of 27. So you end up with the 4th root of 27x over 3. Whew, that was a little bit tricky. So f negative 1 of x equals the 4th root of 27x all over 3, because you can't have a root on the bottom. So that is how we can do it with powers greater than 2, meaning now maybe we got a 4th, a 5th, a 6th, whatever. What I want you to do now is I want you to try on the bottom of page 14 in your notes. I want you to try this checkpoint, and I will put the answers online. Good luck.